Welcome to Doozer Shop. I've been working on the Clausen Colchester apron, the half nut mechanism. I've got some progress. I'd like to show you where I'm at with it. Thanks to some of the guys that commented, a couple people had some good observations. Couple said maybe there's not really a problem because it worked before and it was crashed, and I'll show you what I did to fix some of the crash damage that I believe I found. The reason I'm really scrutinizing this mechanism is you guys who use a lathe know if you're threading and you're threading towards the chuck and you got a stop groove or a chuck you're going to run into, you want to pull that half nut, you want to stop very quickly. And if there's any binding in that mechanism, I've had two friends I know that are machinists that have had this happen on their lathe. One nicked a jaw on a brand new Buck 6 jaw. Nicked a hard jaw because the threading lever wouldn't disengage. Or maybe it was the feed lever. I can't remember, but similar situation. So let me go handheld and let me show you for what I've been working on since last week. And I remember to put my glasses on, because I can't see. Alright. So here we are. So one of the things that a few of my viewers, either I mentioned it very quickly or didn't mention it clearly, is this. So this is an angle plate. I call it that because that's what it looks like. And it's cut out. About the brass in a minute, but you can see it goes on there. And that's what I was working on. And there was a space between the end of the half nut and this plate, and I took it up with a shim. And I mean, there was like, so I had this shim stock from the trash bin at work. This shim stock, I just happened to have it laying on the bench, and when I had this piece bolted on, so there is some shake in there because there's a gap between the half nut and the angle plate on this side. So I just took a piece of that shim that happened to be laying on my bench, and I know I got it from the dumpster at work, and I stuffed it in there, and it took up the gap just perfectly. And I says, okay, how about this for an idea? How about I solder a piece of that brass stock to this little iron plate, and then I can so I can put this in the surface grinder vise, in the grinding vise on the mag chuck of the surface grinder. So I know this face is 90 degrees to this face, and what I do is I put it in the surface grinder vise, and I referenced this surface to the bottom, so that I licked off on the grinder. That bottom's flat. So I set it on the bottom of the vise to the back of the vise, and then I use like a spacer. Actually, I use like a bolt, and I put it in that countersink, so I'm not squeezing here or on that angle part, that brace. I'm squeezing it up against the back jaw of the vise. So anyways, so I soldered that on there, but let me back up. So I took that off, and then I noticed there was a hairline crack in this piece, and if I remember, there's one end of it, and the other end is there, where my thumb is. So there was a hairline crack from there to there. So basically, where my thumb is showing, diagonally across there, there was a hairline crack, and you could kind of see, you know, it's kind of hanging out in the breeze. But it wasn't all the way through, so I V'd it out, and I brazed it in, and then I surface ground the braze that I did, and then I tinned. So this is cast iron. I tinned the face with solder, and then I tinned the back side of this brass with solder, and then I put them together. I put a little weight on them. The weight, you know, to hold the brass in place, and then I reheated everything, and it just smushed together, and that was that. So, as a side note, I was just using regular 50-50 solder. Actually, I was using 60-40 electronic solder to try and tin the face of this iron plate, which had been surface ground, so I know it's... So it had been heated up to braze that crack, and then it had been surface ground to clean it up. So I say that because when you heat this to braze it, it cooked all the oil out, and if I was able to braze it, all the oil was definitely cooked out. And then I had a virgin surface from surface grinding it. So solder should have stuck to this. And I used regular zinc chloride flux, which is just regular, like OD number 5 plumber's flux is zinc chloride. Most people don't realize that flux is zinc chloride in a the vehicle is petroleum jelly, right? So that's why the flux looks like Vaseline, because the zinc chloride is suspended in petroleum jelly. And I had a hell of a time. About half the surface would wet and half just wouldn't. And then I cleaned it with, I would apply more flux while it was hot, and then it would etch it some, and then it would apply more solder, and just I'd float it around with a coffee stir stick and just try to move it around. And I thought I had it fluxed pretty well, and then I put this on, and I started surface grinding it, and then it came up. It just wasn't stuck. So I peeled it off again. I'm sorry this is so long, but I peeled it off again. It fell off, and what I did, I cleaned everything, cleaned the old flux off with lacquer thinner, and I wire brushed the heck out of it. Cleaned it off again, and there's the residual solder on. That's fine. And I clamped it. I had it clamped in a little drill press vise on the welding bench. And I had some lead-free solder for plumbing, right? This modern plumbing solder is lead-free. Let me show you. I think it's 95% tin and 5% antimony, and antimony is like lead, but it's not lead. Alright, this is just regular paste flux, and it's zinc chloride, Lennox, so this is OD, I think. Yeah, zinc chloride. It's the same stuff, folks. Manufacturers, do not put flux in a plastic tin, plastic container. Put it in a metal tin, because then you can heat it up with a torch and remelt it. I even was just heated it up and I was pouring the flux out the side on my little angle bracket. Don't put flux in a plastic thing. Use a metal thing. Come on, people. Yeah, okay. Rant over. Oh, there you go. Lead-free antimony free. Okay. So 95.6% tin, 4% copper, and 0.4% silver. Okay. All right. So it's lead. I'm sorry. So it's tin, a smidge of copper, and just a micro smidge of silver. Okay. So the copper has just got to be powdered copper as a filler, right? I don't think that would add in the soldering reaction. But this stuff's, I don't know if I said that. This stuff, it stuck. And this is soft solder. That's high temperature brazing flux, that stuff. And then, silver solder, comes in these sticks. And this is Harris, I don't know what the hell that says. Harris 15, So this is silver solder, and you use that with that. I was using soft solder, just so you guys know. Okay, where did I leave my, oh, here it is. Yeah, so that was a success. 10 minutes talking about a little goofy thing. But it welded out wonderful with that lead-free solder. So it's 0.2% silver. I don't know what the real silver solder is. It's probably like 5%. So, alright. You're welcome. Dissertation on soldering cast iron. Use the new plumber's lead-free solder. It works better. Don't know why. Maybe that little extra silver, that 0.2% silver is the key. Bada bing. But this thing, I put it on, it was still having issues, and I need more than... So these screws, they're flathead screws, they were bent. So first I thought the heads were made eccentric, because you tighten them up and the bracket would boogie around a little bit. But it turns out that these were bent a little in the shank. I choked up as far as I could with the 5C collet. It was going in the lathe there, and you see the angle. I just angled the tool bit to mimic that. Well, these are 82-degree American standard flathead screws. But apparently it was bent in the shank, and I chucked up too far, so after I cleaned up the heads, they were still bent. Whatever. So, more evidence that this was crashed. This thing was cracked diagonally across here. I got some new screws. The heads are a little bigger. I don't know if I'm going to trim the heads back down or countersink these holes a little bit more. Let me show you. Alright, let me put the camera down. Alright, you guys can see this. So, first of all, not everybody, some people were asking about, is this square? And you know what? So this back surface is pretty close. I mean, it is, as far as I can ascertain, it's parallel with the threads. Or let's just assume it is, without talking how many thousandths or tenths or whatever it's off. So now, if you do this, okay, there is the slightest gap here, and it's touching here. So this is the high point, and I can't even, I don't know if I can show you. I mean, that might be off by 5 thou, okay? There might be a 5 thou. I don't know if you can see that. But trust me, it's like 5 thou. So this is low and this is square. If you want to do the other side like that, okay? Well, I forget we're doing videos here. that's square. So this bottom side, this is square with the back. I mean, I'm not gonna say perfect because I'm an engineer. I can't say perfect. It's very square within like a thou or less. Okay. No, I didn't measure it, but I can eyeball, and this square is a very good square. Okay. So when I put it on there, that's touching. There's about 5 thou air under there. That's why this hits first. Okay. I'll set all that. Put that back in. Okay. Now this is a good surface. Some guys are asking, is this a good, where this bushing is? That's flat. So yes, this thing, and it binds at the bottom a little bit, but that's not what I'm talking about. It binds because it's sitting on this lump of cast. This was spot faced around, and this is the cleanup. I could go in there with a hand file or a Dremel with a burr. Maybe I should clean that up. But that's not the problem. The problem, okay. So that slides in there. I kind of like it with my spring, okay? Like it with the spring. I know it's upside down, and somebody mentioned, yes, gravity is affecting it. Then you should just turn it right side up and run it. I get that. Okay, so that's in there, and when you have some slop, if you push it so this is contacting there, that's square and this is straight, and that's really good. Now, the angle plate, you guys see that? Yeah, goes on there. All right, you know what? Let me put it on. Drag my stool over, and I'm trying not to get in front of you guys with the camera. I am not a videographer. I am an engineer. But this is pretty fun. Alright, I'm just going to lightly snug that. Alright, and I know I got to cut the heads down a little, whatever. So, you wiggle this. I'm just going to tighten these barely snug, okay? Alright, so now, I'm going to loosen this just a smidge. I got to grind, surface grind, like another 3, 4, 5 thou off of that. Alright, so there's some running clearance, some operating clearance. So predominantly it's forced up against here. You know, I mean this thing, I mean it's wiggling just a bit. So let me engage the cam. Alright, so the cam is engaged, okay? The cam's engaged. So now it's, okay, the half nuts are, there's up, well, down, up, down. Hold on a sec. Let me re-index the spline on the handle. Come on. Alright. Now. So that's disengaged. That's engaged. Disengaged. Okay. So when it's engaged, it's in the sweet spot. Okay. When it's engaged, it's in the where the cam is more horizontal. When I disengage it, the cam it actually disengages pretty well. It disengages pretty well. You know, if I had my shorter stool, I would be speaking more at the camera. I'll try to slouch, right? And as you can see, it works. This is not tight though. Let me try and tighten this a little, because it's flexing, right? Okay, it's still not too bad. Okay, I got it tight. Well, I'll be darned, it really works pretty good, pretty well. Huh. So that's the high point, which is engaged, and that's the low point. I'm actually going to tighten that a little more. Well, dang. That doesn't move too bad. Let me get some oil on it, you know, because things work better with oil. So I had played around with this. Let me grab the oil can. I'll be right back. All right. This is ATF. This is really light oil. So let me put some in the cam slot. I'm going to try not to get too much out there. Alright, now let me get a little here, 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 and let me get some on the post. Wow, get a little here. I'm not putting a lot on. Alright. Alright. Well, darn if that don't work pretty good. I mean, that works really, really well. Let me tighten these just a smidge more. Wow, that's pretty good. Maybe I'm all right. Maybe I'm fretting for nothing over this. But this thing was definitely jacked up. For whatever reason, it needed that shim in there. It needed it. Because this thing would twist like crazy. And I'll give you a secret. This... It was a bear to get that piece of brass to sit flat when I soldered it. And I put a weight on it and I reheated it. I got it on there. And then I surface ground it on the surface grinder. And I didn't measure anything. I just stopped when I got full cleanup all the way across the piece of brass. You know, you do minimal cleanup. You keep going until you get the full surface coverage where you're grinding. Maybe this will be okay. Try something. Let me loosen this screw. This one's tight. If I loosen that and retighten it, does it change anything? Oh, wow. It actually works better. So that's tight. Okay. Let me loosen this one. Okay. Now let me retighten it. Okay. You know, last time I tried this, it wasn't as free as this off camera. I swear. I was set to make this video and solicit more suggestions from you guys. I think I've done this before. It makes a difference if you swap these two screws. I think it shouldn't. It should be the same, and they're not eccentric. They're not like the old ones were. The old ones were bent because of a collision, but this is not the case. I don't know. It's working now. I expected to make this video and this thing was going to be jacked up. I mean, I've never seen it operate this smooth. I mean, this is like, wow. Okay, there's a little, right at the end there's a little bit of, just, no? Excuse my big head, I'm gonna look. Well, that's where it hits that. I'm gonna file that off at the bottom. Folks, it's working really well. I can't believe it. Let me grab the camera and give you a better close up here. I'm astounded. This is working so good, so well. Hold on. All right. Shake, rattle, and roll. So you can see what I'm doing back here. This is the lever, and it's on a spline. Okay. Let me switch hands here. Try not to drop the camera down. Look at that. So that's engaged because it drops it down and it picks it back up. Damn, that's awesome. It would never get that high. It would be there to there, there to there, there to there, there. Well, I think this is a successful repair. That's just freaking amazing. I have nothing left to talk about. It's working. All right. So, all right, switch hands again. So this half nut mechanism, let me kneel down on my chair here. This post being in there, this is all a compromise of design. If this had been like a south bend, I remember my old Atlas lathe was even like this. These half nuts, it's a single half nut in this case, but usually they're in tongue and groove slide, right? Like a boxway slide, where it's got the half nut itself is made onto a plate, and there's like a female slide, like a female groove there, and a female groove there. And it's guided, it's got a face, and the face is guided up and down. So it can't twist and rotate. This, because of the post, that central guide post, it's allowed to twist and rotate. It is allowed to twist. So I think this is, on Colchester's part, a compromise in design for something that's possibly easier to manufacture. Like I said, South Bend and Atlas have tongue and groove slides on a mounting face that guide the lower and in the upper. In their case, they have two halves. I've seen more expensive lathes have dovetail slides, just like a regular slideway with dovetails that guide the half nuts on a face type of a slide situation. But I think this post on Colchester's part is sort of a compromise, because you get that twisting element to it. Yeah, you get that twist, but it's working well. All right, there's engaged. It's going to pick it up. or in this case drop it down because it's upside down on the bench, it's working pretty good. Wow. Alright, well, I'm either going to countersink these a little more or turn the back heads of the screws. I'm almost afraid to countersink them because it'll change the alignment. Alright, well, that's the update from Doozer Shop. I was fully expecting to solicit more advice from you guys on how to make this thing work. But this worked out, and you can see these notches here. 1, 2, 3 is where the lead screw had been rubbing on that bracket when it was held stationary in threading mode. I might take a die grinder and clean that up. I just can't believe that this thing's working that smooth. Alright, so I fretted for nothing, but it was a good engineering analysis. I thought, I guess if it binds up in use, I will revisit it and let you guys know. We'll take it apart again. Yeah, I'm kind of psyched. Wow, okay, alright. So what else is going on? That's about it. So thank you guys for bearing with my analysis on this. I don't know why I needed to put a shim in there. I don't know what the clearances were set from Colchester. You know, fitters put these lathes together back in the day. Supposedly, this lathe was made on an assembly line, a moving floor assembly line. So I don't know if this lathe was built with fitters, guys who fit the parts per se. These parts just probably had to fit because, like I said, according to the information on the UK Lathes Tony Griffith's website, these were built in a production with the moving floor, like an automobile factory. I guess trying to mimic Henry Ford, whatever. So this could have been an oversight where this should have been fitted tighter the way I have it, that shim soldered on there. I need to send Keith Fenner an email and ask him how his half nuts work. They probably work fine and I'm probably just crazy. But, okay, retracted, engaged. Retracted, engaged. Okay. I like it. Like I said, it'll never drop that far down. I guess it works. And I guess if I oil the lead screw, the oil's going to get on that face. Because the screw's going to get oil on it. It's going to be dripping wet. Yeah, it should get oil. And you know we got the feed pipe to the other side of this. Yeah. That's the feed pipe, which will have a Gitz cup, and it's upside down. But that pipe comes through and feeds that in there. Let me kind of drop the screw. There it is. There's the feed pipe, and it almost touches the gear. I swear it has a less than a 1/4 inch of clearance. But that feeds that that alignment post. So should be good. I'm sorry it's a long video. Dislike me, whatever, I don't care. It's just this video is up for people that have a 17-inch Colchester. Alright. Until next time, thanks for watching. This is Doozer's Shop.